Now today we're going to start with our brand new enhancement, which is feature detection and machining, and we're going to go over that in SOLIDWORKS, and I'm currently running SOLIDWORKS 2017. So as you can see, VisualCAM 2017 runs in SOLIDWORKS 2017 and older versions of SOLIDWORKS going all the way back to 2010. Now we do have for both 32 and 64-bit versions for SOLIDWORKS. Now I have a part that's loaded, and as you notice, when VisualCAM plugin is installed and loaded, you'll see a VisualCAM 2017 tab that shows up under the Command Manager in SOLIDWORKS, and the VisualCAM's CAM interface appears as a tab right next to your Feature Manager design tree, so you can switch back and forth by just single click of a button. You have the Machining Operations browser, which appears over on the top half of the browser window, and the lower half includes the Machining Objects browser, which has tools, machining regions, features, and knowledge bases. Your workflow would be typically going from left to right as you work through each of these groups under the Program tab, and then you switch over to the Simulate tab to run verification. So to detect features and be able to machine these features, I would go over to the Machining Objects browser and then click on the Features tab under the Machining Objects browser and select Create Machining Features. I'm going to select the face of this part and pick OK to accept it, and you'll now notice that the features are being detected, and the detected features automatically appear under the Features tab in the Machining Objects browser. So the feature detection and machining, in this case, we're working with the prismatic part. You'll notice that several different feature types have been identified. We have a planar face, we have prismatic pockets, just identified all of these pocket features, and we also have a hole feature in here identified. There are several feature types we detect for both 2.5 axis and also 3 axis. I will give you an overview of all the different feature types we currently detect. Now once we have these features detected, you could program toolpaths by right-clicking on a feature and the feature tree and selecting a machining operation. So I'm going to choose facing, and you'll notice that the feature is automatically added. We'll make a selection for the tool, specify the parameters, and then generate produces the toolpath. In the next step, I would like to program these pockets. So select the prismatic pocket features, right-click, and I'm going to choose pocketing. So depending on the feature type, you'll notice that the operations that are available to you are automatically filtered. So for a pocket, you could either do a pocketing or a profiling operation, and if you have an open pocket, you could also do a facing to program an open pocket. So those are the 3 different operation types for prismatic pockets. You'll notice that all of these features have now been selected. We'll make a selection for the tool. We'll establish our cutting parameters in here, and then choose Generate. So the toolpath for the prismatic pockets has now been generated. Finally, I would like to program the hole features. I'm going to select the hole feature in the tree, right-click, and choose hole pocketing. So if you'd like to do drilling, a pre-drill operation, you could do drilling first and then do a pocket. So in this case, I'm going to go directly to a hole pocketing operation. The hole feature and the hole cross-section is displayed under the Hole Features tab. We'll make a selection for the tool and then pick Generate. Now you'll notice that with the feature detection and machining, all of your parameters in here, like the hole depth, all of this is automatically established based on the feature that's being identified. So this saves you time in having to go in and input these parameters as they're detected based on the features automatically. So we now have programmed the part with 3 operations, the facing, pocketing, and hole pocketing after identifying these features. Now once I have these operations programmed, I'm going to go over to the Simulate tab to run a verification. So I'll switch over to the Simulate tab. I currently have a stock model defined in here. I'm going to select the operation and click on the play button to run a verification. So now we have successfully programmed the facing, pocketing, and hole pocketing. Finally, I could also add a profile to relieve the material from the stock. So I'm going to go back to the Features tab, select the planar face, right-click, and I could choose Profiling, and the feature is automatically added. Now, if you'd like to specify any of the parameters like your finish depth per cut, any of these steps in here, you can specify also, and also specify your depth per cut, and then pick Generate. So profile path is now added. I could run a verification of it from the Simulate tab. So these are one of the ways of identifying features and machining it. The next example I'm going to go over is detecting features of additional feature types. And in order to do this, I'm going to bring in another example. In this particular step, we will be identifying slot features on this part. So you notice that the part here is a prismatic part. You have two slot geometries for each feature in here, and we'll go ahead and identify these slots. So the steps are very similar. We'll go to the Features tab under the Machining Objects browser and click on Create Machining Features, select the face, and accept it. So you'll now notice that the planar face feature has been detected and all of the slot features have been identified. So there's a total of 8 slot features being detected right in here. And as you select each of these slot features in the feature tree, the corresponding feature is now displayed, previewed on the graphic screen. Now, if you'd like to program the blind slots in here, you can just basically select the features from the feature tree, highlight them, right-click, and you'll notice that you can now select slotting. So the slotting is a new operation type that's offered in 2-axis machining operations. And the feature detection machining and the slotting operations are offered in our mill configuration starting with standard. So if you're running standard, expert, professional, or even premium configuration, you'll have access to feature detection machining and the new 2-axis method for slot machining as well. So I'll make a selection for the tool and then choose Generate. Now, depending on the slot width and the tool geometry that's selected, you will notice that in the case where the slot width is larger than the tool diameter, the toolpath generates is a trichordal toolpath with constant tangential arcs. In the case where the width of the slot equals the tool width or the tool diameter, you would create a single pass slotting operation. So I'm going to pick a tool, use the same tool in here, and then select Generate. You'll notice that in this particular case, the cutter diameter is 1/2 inch, and so is the slot width. So there's a one-pass cut pattern that's generated for slotting. Now, the slot machining, you can also program this in the traditional way that you've been used to programming by going up to 2-axis machining. You could select slotting, and you can choose select curved edge regions and select either a sketch, or you could select a chain of edges by graphically selecting those from your graphic screen, and you can make a selection for the tool and generate it as well. So 2-axis slot machining is now available in version 2017, and it's included starting with the standard configuration of our mill module. Now we've identified closed slots in here. Our feature detection and machining can also detect and identify open slots as well. So I now have an example in here which demonstrates how to program open slots. The process is very similar, so we'll go to the Features tab under the Machining Objects browser. Now, if for any reason you're unable to view the Features tab, you can click on Tools and Machining Objects to toggle the visibility or the display of the Machining Objects browser. We'll now go ahead and click on Create Machining Features, pick the face, accept it, and the slot features are now identified. In this case, it's an open slot. We have these slots identified. Right-click and select Slotting. Make a selection for the tool, Generate. Now in the event where the tool diameter is smaller than the slot diameter, I'm going to swap the tool out in here. Use an 1/8 inch as opposed to be using a 1/4 inch. You'll notice that you can drag and drop tools from the Tools tab over to the machining operations, and as you make a change to the tool, the operation is flagged dirty, indicating that you made a tool change which requires regeneration. So you can right-click and select Regenerate to update your toolpaths. And it produces the tricartal toolpath as the tool diameter is smaller than the slot width. If you'd like to add additional passes in here, you could always edit the operation, and under your cut levels you can specify your depth per cut to create multiple Z levels, multiple cut levels. Now as you can see here, we can identify hole features, closed pockets, open pockets, non-prismatic pockets. This would be requiring you to program a 3-axis operation. We could identify boss features, through slots, through T-slots, prismatic slots, and planar faces. So these are the different feature types that can be identified and machined using feature-based detection and machining.